I'm going to show you how to do the appropriate statistical tests if you've got different groups of data and you want to see if there are statistically significant differences in the means between them. So I'm going to be using Excel to do a one-way ANOVA followed by Tukey's HSD tests. So I'll just give you an overview quickly of what this does using this example data here. So I've collected a rate of reaction data for 6 different temperatures. So I've got my different temperatures down here. And you can see I did 5 trials at each temperature. This is my raw data for the rates of reaction. And then I've calculated a mean for each temperature and a standard deviation. And I've plotted that in the graph here. And you can see that temperature is having a clear effect on the rate of reaction. This is an enzyme, so this is the typical graph that you would get for that. Now I'm going to use the ANOVA to test whether temperature has a significant effect on the rate of reaction. Now looking at the graph, I think it's quite clear that it does have a significant effect. But more interestingly, what I'm actually trying to find out is, well, what is the optimum temperature for this rate of reaction? Now looking at this, I can see, well, the highest rate of reaction seems to be at 50 degrees, but 40 degrees also had a very similar rate of reaction. The error bars overlap, so it's difficult for me to see whether these two are significantly different from each other or not. Is 50 significantly higher than 40? Also, the rate of reaction at 40 degrees, although higher than at 30 degrees, there's a bit of overlap in the error bars, and so those two might not be significantly different. So I would need to know, well, how to do this. You could use t-tests. However, it's not the correct way of doing it if you're going to be doing lots of pairwise comparisons. Pairwise comparisons means I'm going to be comparing 20 with 30, 30 with 40, 40 with 50. I'm also going to be comparing 20 with 40, 30 with 60. I'm going to be comparing every single mean with every other mean. And for that, we use Tukey's HSD tests, which can be done after you've done a one-way ANOVA. Now to do that, I need, so I'm using Excel, but Excel itself can't do it. You need to install an add-in. Now, if I go to Tools and I go down to my Excel add-ins here, I can see I've got this add-in called XRealStats Mac. I'm using an Apple Mac computer, and that's the add-in that you need. You can install that from this website here called realstatistics.com. You need to go to free download. You need to select which, whether you're using a PC or a Mac, which operating system you're using. You're going to install that, and then you're going to add it into Excel. And when it's added, you're going to see it in this list here. Now, so I'm going to be using RealStats to analyze this data. Now you can see that my data table is organized with my independent variable, that's my temperature, in a column on the left, and then every other column is a separate trial. So for all the values for 20 degrees, run in a row like that. Now, RealStats needs the data organized like this, where you've got columns. Each column is a different temperature in order to do the comparisons. So you can see here for 20 degrees, my values were 3.4, 3.5, 7.1. Here I've got 20 degrees, 3.4, 3.5, 7.1. So I've just copied and pasted these down here. Now, on an Apple computer, first of all, I'm going to select where I want the output to go. So I want it to be there. And then I'm going to press 2 keys at the same time. I'm going to press Control and M. Control and M, and it brings up this dialog box. So again, this is the real statistics add-in. You don't get this in Excel normally. I'm going to click on ANOVA, and I'm going to do a one-factor ANOVA. One factor means that I've only got one independent variable. And I'll click on OK. Now, I'll go through the different steps here. First of all, input range. This is the range of input data. Now, here's my input data. The top left one is in cell B12. That's where it begins. And the bottom right is in G17. So I'm going to type B12 colon G17. So it knows where to read from. I'm going to leave this box ticked, so it means column headings included with data. So that means that the top row is column headings. This is not raw data. These are the values of my independent variable. Alpha, I'm going to put at 0.05. That's just the what is going to be my critical value for the p values, and 0.05 is the standard. The input format is Excel, because I'm using Excel. I'm going to be running an ANOVA, and I'm also going to be doing a Tukey HSD test. So the ANOVA is going to be testing, is there an effect of temperature on rate of reaction? And then the Tukey HSD test is going to be comparing each of the temperatures with each other to see which ones are significantly different from each other. I'm not going to click anything in this box here. Down here, it's because the tests I'm doing, it's not even going to consider any information in this box, but it's worth you knowing what it is. Because we're going to be doing lots of statistical tests, the chance that one of those comes up with a p-value of less than 0.05 becomes fairly probable. And that's an issue you get with statistical tests when you do lots of them. Some of them, just by chance, might come out as significant. So we need to adjust the p-values to account for that. We need to make it more rigorous. A Bonferroni test does that, but we don't need to do that here because it's already done in the Tukey HSD test. So I don't have to do anything with these bottom two areas. Now the output range, B20, that's where I want the output to go. Okay, that's all ready, so I'm now going to click on OK. Okay, so you can see it's produced a lot of different tables. As a high school student, you're not expected to know what all this information is. So I'm just going to show you what are the important bits that you need to know and what needs to be included in your actual investigation write-up report. So first of all, down here, this is the ANOVA table. So this is looking at here, does temperature have an effect at on the rate of reaction? I.e., are there differences here at all? Now, what it's doing, it's looking at the variation between the groups. So for example, this and this and this and this, and it's looking at the variation within the groups. So the standard deviation. And it's saying, well, which is bigger? So you can see here, this represents the variation. So you can see the variation between the groups is much greater than the variation within the groups. And therefore, it gives a p-value of this. This means 2.168 times 10 to the power of -13. That's a really small number. It's basically 0.000013 times 21. Now, in our report, we don't write that. We can just write p is less than 0.001. Okay, it's a simple way of showing it's really small, rather than having to write out this exponential number. Okay, and I'll show you later how do we write this in our actual lab report. Now, what's more interesting in here is comparing the rate of reaction means between the different temperatures to see are they significantly different from each other. And that's what this table down here is doing. So first of all, I want to see, is there a significant difference between 20 and 30 degrees? Now, looking at the means, I can see, yeah, they look really different to each other, and there's nowhere near any overlap between the error bars from the standard deviations. Now, I can have a look at the Tukey test, and I can see, well, there's 20 degrees compared with 30 degrees, and the p-value is here 1.1 times 10 to the power of -5, also very, very small. So that's a highly significant difference. But now look at 30 and 40 degrees. The means are clearly different to each other, but there's some overlap in the error bars, meaning that there's some overlap in the variation. So it's not clear whether these two will be significantly different to each other or not. So I'm going to look at the Tukey HSD table here, and I'm going to look at the 30 and 40 degrees, I look at the p-value and I get a value of 0.0186. Although higher than this value here, it's still clearly significant because it's less than 0.05. So the difference here is still significant. Now I'm going to have a look at the difference between 40 and 50 degrees because the means are quite similar to each other and there's a large overlap in the standard deviation error bars. So looking at the Tukey test, I can see here 40 and 50 degrees. I scan along, there's a p-value of 0.957. That means that there's a 95% probability that these two, that the difference here is just by chance. So that's not significant at all. So with the Tukey's HSD test, I can show that these two are not significant. Now looking at the 50 and 60 degrees, I can compare those, and again, it's a highly significant difference, as I would expect. So, okay, what does this tell me overall? Well, I'm trying to answer the question, which temperature has the highest rate of reaction? I can't say that 50 is higher than 40 because there's no significant difference. So all I can say is that there is no significant difference between 40 and 50 degrees, but they are both significantly higher than any of the other temperatures. So what I can, and I didn't collect data for 35 or 55 degrees. So what this is saying is, in theory, the peak could be here, okay, and then come down like that. Or it could be that the peak goes up, that the rate of reaction goes up and the peak is here and then goes down. I don't know because I didn't collect data at these temperatures. So all I can say is that the optimum temperature must be between 30 and 60 degrees, but it's probably between 40 and 50 degrees. In order to narrow that range down, I would need to also collect data for these intermediate temperatures. Right, so how do I write this in my lab report? First of all, you do not need to paste all these tables in, but you do need to give the p-values. And so I'm showing you here how you would do this. Okay, so in this paragraph here, I've written an example of how you would do this. So first of all, I'd write my conclusion, and then I would just say one-way ANOVA, and then I'd give the F value. Okay, so that is this value here. Now you can see this gives degrees of freedom. You're not expected to know really what this means, but there were 5 degrees of freedom between groups, 24 degrees of freedom within groups. And then the F value is that 68.16. So I give 5 with a subscript 5, sorry, F with a subscript 524 equals 68.17. That's the F value. And then I give the P value. The P value is less than 0.001. Then I give the values for Tukey's HSD test. So I say there was no significant difference between 40 and 50 degrees, and then I just give the p-value for Tukey's test. Yeah, and then I said, but both these temperatures were significantly higher than all the other temperatures, and now I'm just going to give the important ones. So comparison between 30 and 40 degrees, the p-value was this, and between 50 and 60 degrees, the p-value was less than 0.001. So that's how I would put it into my report. And I hope that's helpful for you.